Hello, Mr. Werner here, back again. Now in this case right here, we're going to take a look at another application of the FTC. Now, in this case, we're not having to do the integrals themselves, but they're giving us this graph. Now this is the graph they tell me of the derivative. I always identify it. You're my derivative. Okay? You're my change in something. And they give us this initial condition. Now, what they're giving us is a derivative, and we want to find the value. So remember, to go from a derivative to a values, and that's what we're looking at over here, all of these values. In order to go from a derivative to a value, we have to take the antiderivative. So if I want to find f of 0 here, I'm going to take the antiderivative of my derivative here. And now, I have to come up with a domain because I am going to use the FTC. Now, they give me 0 is what I'm looking for, and I've got this initial condition at -2. So I'm going to start with my initial condition at -2 and 0. End at 0. I like to go in numerical order. You can switch it around, 0 to -2, but then you just have to put a minus on the outside, if you may remember. Now, using the FTC, this becomes an f of 0 minus f of 2. And you may recall, this is just area under a curve. That's my area function. Well, between -2 and 0, it's a triangle. I know that area, 1/2, the base is 2, the height is 4. That's going to equal f of 0, which I'm looking for, minus 5. That's what I know. So now I can solve for it. F of 0 equals, well, cancel 4. I get 9. So my value at 0 is 9. So if I go and try 2, same idea. Now I could start again at -2, go all the way to 2. But since I just found 0, I'm going to start at 0 to 2. F prime of x dx. That's going to equal f of 2 minus f of 0. And again, I'm looking for this area between 0 and 2. It's a triangle. So again, it's 1/2. Its base is 2. And the height is 4. And that's going to equal f of 2, which I'm looking for, minus 9. And those 2's cancel, and we should get f of 2 equals 13. So the value at 2 is 13. Very easy to do these. Let's try number 6. Now for a question like number 6, same idea. Again, I could start at -2, but since I just found the value at 2, the x-axis, I can start there. From 2 to 6, f prime of x dx. And if I do the area again, this becomes, the antiderivative, my FTC. We get f of 6 minus f of 2. Be careful, this time it's a circle and it's below the x-axis. So it's going to become -1/2 pi, the radius is 2, squared, minus f of 6, which is what I'm looking for, minus f of 2, which I found is 13. Therefore, I can get f of 6 equals 13, bring the 13 over, minus 2 pi. And there we go. Very easy to do. We could even use these to find absolute max and mins, like if I did want to do my candidates test. Okay, very easy to do. So where would be my absolute maximum? At 2, because the slope goes from positive to negative, and I've checked all my candidates, endpoints and everything. So very easy to do these. So we can take a look down here real quickly. Same idea. Now they gave me these areas. This section of circle has an area of 4. Down here, be careful, -9. They're not going to tell you it's negative. You have to remember it's below. Here the area is 2. So if I want to find the value at 0, they give me this initial condition. I set it up. 0 to 3, f prime of x dx equals f of 3 minus f of 0. This area from 0 to 3 we know is 4, equal to f of 3, which we already know is 5, that's my given, minus f of 0. So therefore I can get f of 0 equals to 1. So the value at 0 is 1. If I want to try at 7, well, same idea. Now, same thing. I could start at 0. I could start at 3. It doesn't matter. Your choice. I'll start at 3. 0 to 7. F prime of x dx equals f of 7 minus f of 3. And the area from here to here, be careful, that's our -9, equal to f of 7 minus this f of 3, which is 5. So we get f of 7, which becomes, what's that, -4. Very easy. and I can find f of 9. So between, and I'm going to start at 7 again. I can start anywhere I wanted to as long as it's on the x-axis. 7 to 9, f prime of x dx. We can start anywhere on the x-intercepts here because remember, we measure area to the x-axis. So these are like my critical numbers. I can use them. That's how we use them here. So we get f of 9 minus f of 7. We know this area between 7 and 9 is 2. That's going to equal f of 9, which is what we want to find, minus f of 7, which we said was negative 4. So therefore we get f of 9 equal to negative 2. And what's really cool is we can now even sketch this graph right here. This is the derivative graph. Now let's sketch the original function. So to graph the function, we've done this before. 1, you need some points. Now we just found them. They gave us the point 3,5. We found 0, 1, 7, negative 4, and 9, negative 2. Next, we need to find max and mins. Now to find max mins, that's right, we have to do the first derivative test. Where is our derivative equal to 0? And we got that from up here. 0, 3, 7, and 9. 0, 3, 7, and 9. I do my first derivative test. F prime of x, f of x. So I get my 3 and my 7. 0 and 9 are already in points. We got positive, negative, positive. So it goes positive, negative, positive. Up, down, turn around. And what I have is that 3 is a max, and that 7 is a minimum. So if I start graphing these now, the point 3,5, not looking for anything perfect, 0, 1, 7, negative 4, and 9, negative 2. What this is telling me now is that 3, we know this is a maximum. And that 7, we know that's a minimum value. So we know it's not going any higher or lower, so I can start graphing my curve. Now the next thing we need is concavity. Now to get concavity, nope, not a dentist, we look at the second derivative, where the second derivative is 0 or d and e. And to do that, I look up here at the graph. Take a look down here. That's where my second derivative is 0. Here, here, and here. So it looks like about 1.5, 5, and 8. So if we do our sign test for the second derivative now, from 0 to 9, 1.5, 5, and 8, now we're looking at the slopes. Positive from 1.5 to 5, negative from 5 to 8, positive, and then negative. So it's concave up, down, Now what I want here are the POIs. The POIs occur at 1.5, 5, and 8. Those are my points of inflection. So if I kind of give like a rough sketch of it right now, that's my rough sketch. At 1.5, there's a POI. At 5, boom, there's a POI. At 8, boom, there's a POI. And for my concavity, I know it's concave up here, then concave down, then concave up to here, and then concave down again. And we have the original function for this one. Alright, now, real world situation, pizza. We all love pizza. So we have pizza with a temperature that we take out of the oven, 95 degrees Celsius. When we take it out at t equals 0, and then then it starts to decrease in temperature. And it's decreasing at this rate. So what they're giving us is a derivative. And we want to find the pizza's temperature, so we want to find the value. We know how to do this. That's our antiderivative. So my rule says I got to find the antiderivative. So finding the temperature at 5 minutes. So I'm taking an antiderivative. So even if I don't know anything else, if I just set this up as an antiderivative, I put my rate inside my antiderivative, 0.1t. Don't forget dt. Okay? Now, it's going to be negative, and the reason for that is because we are told it's decreasing. Don't assume that it's going to be negative for you. They're going to fix it for you. You have to put that in there. Now we need a time change. Well, we're starting at t equals 0, and we go all the way to t equals 5 minutes. And I know that this is going to equal the temperature of the pizza after 5 minutes minus the temperature of the pizza at 0 minutes. So it's my FTC. This is going to give me how much the temperature of the pizza is changing. And I can do this very easily with the calculator. Okay, math 9. I'm using my old calculator here. If you want to use the other calculator, just come see me. Plug in the negative. I get 6e to the 0.1t to the negative 0.1t. We've got to use x here. Close it, comma x, comma 0, comma 5. I hit enter, and I get this negative 23.608 degrees Celsius. Now remember what this means. This is the change in temperature. That means the temperature decreased in those 5 minutes about 23 degrees. And that's going to equal f of 5, when I want to find it, minus the initial temperature, which is 95 degrees Celsius. So I can get the new temperature. And if I just use my calculator, if I add 95 to that, we get 71.392 degrees Celsius. Okay, now if you forget the negative, here's what's going to happen. You're going to add that, you can get like 110 degrees. Now, if you take a pizza out 95 degrees and put it into your room and it increases to 110 degrees, you might want to get out of that room. It's a little warm for you. So make sure, be very careful. Make sure it makes sense. If your answer doesn't make sense, go back to the drawing board. Most of the time you forgot your negative. All right, well, that's today, so have fun with these, okay? I'll see you guys later. Bye-bye.